On February 17, a glowing green comet makes its closest pass to Earth. It's roughly city-sized. It's brightening right now, and it's on a one-way trajectory out of the solar system. A lot of people assume this is another 3-eye atlas. It's not, and what's happening here is just as fascinating for a completely different reason. This is Comet C 2024 E1, also known as Wierzchoś. It was discovered in March 2024 by Polish astronomer Kacper Wierzchoś. Since then, telescopes, including the James Webb Space Telescope, have been watching it closely. On February 17th, it makes its closest approach to Earth. After that, it begins fading. Not because it's slowing down, because it's leaving. February 17 is the comet's closest Earth approach, about 151 million kilometers away. That's roughly the distance between Earth and the Sun. It won't be visible to the naked eye, but with binoculars or a decent telescope, observers in both hemispheres can spot it, especially after sunset. This week marks peak visibility. After this window, it gets dimmer, smaller, harder to track. But here's the key point. This isn't just a close pass. It's the last time this comet will ever come near us. Now let's clear something up. This is not an interstellar visitor. Unlike 3-eye atlas, which entered the solar system already unbound, Comet Wierzchoś formed here. It likely originated in the Oort Cloud, that vast, distant shell of icy bodies surrounding our solar system. For millions of years, it drifted in deep freeze. Then gravitational nudges sent it inward, but its orbit is hyperbolic. That means it does not loop back around the sun in a closed path. Instead, after this pass, it keeps going. It's not arriving from another star. It's a native object being permanently lost. Same fate as 3-eye atlas, completely different origin story. So why is it green? Photos show a bright emerald coma, the cloud of gas and dust surrounding the nucleus. That glow likely comes from diatomic carbon, C2. When ultraviolet sunlight hits those carbon molecules, they fluoresce in green wavelengths. The James Webb Space Telescope also detected significant carbon dioxide in the coma, high carbon content, active outgassing. Solar heating near perihelion, which had passed on January 20, intensified that activity. As it swung closer to the sun, frozen gases vaporized, dust lifted off the surface, and the coma brightened. This is peak activity. We're catching it at its most dramatic moment. Early data suggested the nucleus could be up to 13 kilometers wide. That's roughly 2/3 the length of Manhattan. But more recent, non-peer-reviewed analysis suggests that might be an overestimate. Comet nuclei are notoriously difficult to measure. What we can say confidently is this: it's large enough to survive a deep solar pass, and large enough to remain structurally intact as it escapes. Now here's the important part. Its orbit is hyperbolic. That means its total orbital energy is positive. Translation? It's not gravitationally bound to the sun long term. February 17th is not the moment it escapes. It's the moment we confirm it's never coming back. Over the coming decades, possibly centuries, it will drift farther and farther away. Eventually, the sun's gravity will weaken to the point where it becomes just another interstellar wanderer, a fragment of our solar system set loose into the galaxy. Here's what makes this interesting beyond just one comet. We're entering an era where we detect these objects earlier and more often. Some are entering, some are leaving. New observatories, including the Vera C. Rubin Observatory, are about to dramatically increase our detection power. That means more long-period comets, more hyperbolic trajectories, and maybe more true interstellar visitors. For most of human history, objects like this passed unnoticed. Now we're watching them in real time, tracking their chemistry, measuring their orbits, witnessing pieces of our solar system being ejected into deep space. If this comet formed here and is now leaving forever, how many pieces of our solar system are already drifting between stars? And how many ancient comets from other systems have passed through ours, long before we had the tools to see them? February 17 isn't just a sky event. It's a reminder. Our solar system isn't sealed. It exchanges material with the galaxy. Slowly, quietly, constantly. If you want updates on rare optics like this while they're still visible, subscribe. And if you're watching after February 17, comment where you're watching from, because this comet has already begun its long journey out of our sky.